Good afternoon and welcome back to Dr. Logic Awkwardly Does Logic. Last time I defined the test. This time I'm going to show you how to apply it through a concrete example. We're actually going to do two of these examples, one this video, one the next one. In this one, we'll have an instance of a formula which passes the test, and then we'll have an instance of a formula which doesn't. Hopefully these two examples will be sufficient for you to go off, test all the formulas on your own, and hopefully come up with the right answers. So I get up the whiteboard. There we are. And the formula that we are going to test is this one. We have, sorry, I need to actually be able to read my notes in order to be able to write this down properly. Either necessary not P, or necessary P, or possibly P. So that is one conjunct. And the other conjunct is necessarily not P, or necessarily P, or possibly not P. So what I'm going to show is that this formula passes the test. Now, the first thing to note is that this is a first degree formula and it's in ordered modal conjunctive normal form. So I've already done a bunch of the reductions into this format. Now we've got two conjuncts, so we will call this one conjunct 1 and this one conjunct 2. And at this point, we can kind of just divide them and treat them entirely separately. We just need to have that every single one of the conjuncts passes the test. If that is the case, then the entire thing passes the test. But each of the conjuncts get tested separately from each other. So if we take the first conjunction, then we look at all of the non-modalized disjuncts, of which there are none, all of the necessitated disjuncts, of which there are 2, and then we've got our diamond one at the end. What we're going to do is for each one, you get a different color, so each one of these is going to get paired up with this, except I'm not going to be looking at any of the modal operators, I'm just looking at the purely propositional part. So if we look at this, the purely propositional part is the not P. So I take not P and I disjoin that to the purely propositional part of the diamond formula, which is P. So this is one of the generated disjunctions that we have. But then we do exactly the same thing for the other necessitated disjunct, except this gets us P or P. So we have 2 of these new disjunctions that we formed because we had 2 necessity disjuncts. If we also had a purely propositional one, then we would have a purely propositional, another disjunct corresponding to that, and so on and so forth. So what we will have is always, if our conjunction has, in this case, 3 disjuncts, we'll be forming 2 of these formulas. So it's always one less because we are always grabbing from the diamond point in order to form these disjunctions. So now we need to ask, are either of these tautologies? And the answer is yes, not P or P is a tautology. And so this means that conjunction 1 passes the test. So now let's look at conjunction 2. So take conjunction 2. We do exactly the same thing. So we've got 3 disjuncts here. That means we're going to be forming 2 new disjunctions, one using the purely propositional part of this necessity formula, one using the purely propositional part of this one, and in both cases disjoining it to the purely propositional part of the diamond formula. So this gets us, in the first case, not P or not P, and in the second case, P or not P. Ask the same question, are either of these tautologies? Yes, we have P or not P. So conjunction 2 passes the test. Therefore, the entire formula passes the test because there are only these 2 conjunctions. That's it. So really, as I said, describing the test is way more complex than actually applying it. All you need to do is you kind of pair up these bits, and then you pair up these bits, and you test for tautologousness, tautologiness. validity in every model whatsoever under any truth assignment. So there you have it. That is an example of a sentence. It's already in first degree. It's already in ordered modal conjunction, conjunctive normal form, but it passes the test. And that's all that we wanted to do in this video. In the next one, I will show you an example of something that fails the test so that you can both again see another instance of the application, but also see where things can break down and go wrong, because you might be sitting here thinking, gosh, aren't we always going to get tautologies? No. In fact, in the vast majority of cases, you're not, because way more things are not theorems of S5 than are theorems. In any case, join me again next time. Until then, take care.